Okay, so we found these areas and perimeters. Let's take a look now at related shapes. So we're going to start out with triangles here. I'm going to take a triangle. What we're going to be looking at is if I take that triangle and I enlarge it. I'm just going to take this one, copy it, move it. I know in your notes you're going to have to do a little bit more drawing. But I'm just enlarging it. So it's the same triangle, I just magnified everything. When you enlarge a shape like that, all the sides get, basically the length gets multiplied by the same number. So they're proportional. So if this one here is 9 inches, 10 inches, and 12 inches in length. Over here, let's see if I tell you that this side becomes 18 inches in length, I can find these other two sides. Now here you watched me magnify the triangle, so you know it's sitting in the same orientation. But if it's not, we can always use the angles. Those two angles are the same. These two angles are the same. Now with what we've already learned, we don't need to know the third angle because since a triangle has to add up to 180 degrees no matter what, if two of the angles are the same, the third one must also be the same. So we know without being told that this one, those two angles are the same as well. When you magnify the size of the triangle, the size of the angles does not change. They will be the same. So anytime you have two triangles that have all three angles the same, then you know that one is an enlargement or a reduction of the other. So here the 9 was enlarged to become 18. So I'm going to use that relationship. 9 becomes 18. That tells me what factor this was enlarged by. Now then I can use that to find x or y. Let's find x. In this other proportion, other ratio here, where is the x going to go? On top or on bottom? Well, it's going to go on bottom because it's from the same triangle as the 18. What's going to go above it? Well, what side from the other triangle corresponds to the x? It's between the same two angles. That'd be the 10. 10 is from the same triangle with the 9, so it goes on top with the 9. And it's the same side before the enlargement. It's the before of that side that the x is. So we can cross multiply and divide here. 18 times 10 is 180. Divided by 9 is 20. So x is 20 or 20 inches. So we're going to use that same ratio, 9 to 18, because we know the 9 and the 18 are the same side, just one's before the enlargement, one's after, to find y. Is y going to go on top or bottom? Well, it also goes on bottom because it's still from the same triangle as the 18. And the corresponding side, or the side from the other triangle that corresponds to the y, is the 12. So 12 goes on top here. And we cross multiply. 18 times 12 divided by 9 is 24. So y is 24 inches. It's not always quite that simple. We don't always just enlarge them and leave them in that orientation. You might have something like this. If I tell you this angle is the same as this one, and this angle is the same as this one, we now can see which sides correspond. So if I tell you that this side here is 4, and this is 10, and let's say this side here is 12, we'll call this one x. We're going to call this one y. And let's see here. This will be 35. To find x and y. Well, first thing we need to find is we need to find a match up the corresponding sides from one triangle to the next. So let's start over here. X matches up to which side from the other triangle? It's between this angle and the one that's not marked. So over here we have this angle and the one that's not marked. 12 is the one that's between them. So x matches up with the 12. Which side matches up with the 35 on the other triangle? Well, it's between the one that's marked with one arc and the angle that's marked with two arcs. So over here we have one arc and two arcs. That's the y. So the 35 matches up with the y from the other triangle. And then, of course, we've got the 10 that matches up with the 4. They're both between the angle with two arcs and the one that isn't marked. So which of those pairs do we have both numbers for? Well, the 10 and the 4, correct? So the 10 goes to 4. Now let's say we're going to find x. Where does x go in this other ratio, top or bottom? Is it from the same triangle as the 10 or the 4? From the 10, so it has to go on top. What's going to go below it then? Well, the x corresponds to the 12. It's the same side as the 12. So now we can cross multiply and divide here. 10 times 12 is 120, divided by 4, x equals 30. So x is 30. We're going to use that same ratio again. The 10 to 4 is still our known relationship. We want to find y. Is y going to go on top or bottom? It's from the same triangle as the 4, so the y is going to go on bottom, because the 4 is on bottom. What's going to go above the y? It corresponds to the 35. So now we can cross multiply and divide. 4 times 35 is 140. Divided by 10, y is 14. Simple enough? This even works with three-dimensional objects. Doesn't have to be just triangles or flat objects. I can take something like, oh, I don't know, let's say a cone or a pyramid. And let's say that one of them is an enlargement of the other. So this is 8 inches here by 8 inches. 12 inches by 12 inches. Bless you. The height of this one is 12 inches. What's the height of this one have to be? Well, all lengths, and height is just a length, are magnified by the same ratio. So 8 became 12. This missing height is going to go on top or bottom? It's from the same figure as the 12, so it goes on bottom with the 12. What's going to go above it? The height of this one, which is 12. So we'll cross multiply. 12 times 12 is 144. Divided by 8 is 16. So this is that right? No, that should be 18, shouldn't it? 18. So this height here is 18 inches. What do you think? Okay. Now, if you recall, back when we were doing conversions with units of area, if I had something that was 4 square feet, how many square inches was it? Well, I took my 4 square feet, and my conversion factor was not 12, was it? 1 square foot contained how many square inches? 12 times 12, right? 12 squared, or 144. Because it's square inches and square feet, we had to square the conversion factor. So that cancels out. We've got 4 times 144, which is 576 inches squared. Look familiar? So what if I have a triangle that doesn't have any right angles on it, and I magnify it or enlarge it? This side here started out as 10 inches and becomes 16 inches. And they know that the area of this triangle was 80 inches squared. Can I find the area of this one? Well, the ratio of lengths was 10 to 16, correct? The 10 became the 16 when I enlarged it. Now to make this next step a little easier, I'm going to reduce that. Both 10 and 16 can be divided by 2. Gives me a 5 to 8 ratio of lengths. The ratio of areas relates back to this problem here. If it was just lengths, I would have had 12 inches in a foot. But because it was an area, square feet and square inches, what did I have to do to that conversion factor? It was 12 squared to give me 144. Same thing happens down here. I take that ratio of lengths, 5/8, and I have to square it. When I square a fraction, I square each number separately. What's 5 squared? 25. And 8 squared? 64. So the ratio of lengths is 25, or of areas, I should say, is 25 to 64. It's the ratio of lengths squared. So the area of the smaller one is 80, so that goes here. And I'll cross multiply and divide. 64 times 80 divided by 25. Gives us 204.8. That is inches squared. Make sense? So what do you think is going to happen? Well, I take a pyramid, and let's say this pyramid has length of side here of 8 inches and the length of side here of 14 inches. And I tell you that the volume of this pyramid here is, oh, let's see here. Let's say it's 490 inches cubed. And I want to find the volume of this one. Well, again, we're going to look at the ratio of lengths. The ratio of lengths here is 8 to 14. This side became 14 when I enlarged it. Now, of course, that can be reduced again. 8 and 14 can both be divided by 2. Gives me a 4 to 7 ratio of lengths. So now for my ratio of volumes. It comes from that ratio of lengths, but now if you remember when I did like 2 cubic feet into cubic inches, what did I have to do to my linear conversion factor? I took 12 inches and I had to cube it to get 1,728 cubic inches in a cubic foot. So I'm going to do the same thing down here. My ratio of volumes is going to be my ratio of lengths cubed. So 4 cubed is 4 times 4 times 4, otherwise known as 64. 7 cubed is 7 times 7 times 7, otherwise known as 343. So my ratio of volumes is 64 to 343. Now I had this volume here of 490. That goes on top of the 64 because that came from the 8, from that figure. And we'll cross multiply and divide. 343 times 490 divided by 64. Gives us 26.09. That's going to be inches cubed. Does that all make sense? I can see by the full sign across most people's foreheads, you guys have had enough. Page 421, exercise 12.4. What's that?